Hey guys, welcome back. So today we're going to continue with the trend of the beginning of the chapter not being too bad because it's a lot of kind of introductory stuff. So today we're going to be introducing arc measures, which are going to be used for a lot of the more complicated theorems and properties in circles that we're going to be doing later. So today's mostly definitions. It's really just an issue of adding and subtracting. So today shouldn't be too bad. So it's vocabulary and addition. So beginning, first piece of information that we need is the idea of central angles. Central angles are going to be useful for defining what an arc is and measuring the degree measure of an arc. So a central angle, as given away by the name here, is an angle whose vertex is the center of a circle. So if I pick out an angle, we're going to call this ACB, all right? So if angle ACB is a central angle, then C is the center of the circle. So I can call this circle C. So remember, circles are named based on the center. So the center of the circle here is C, that's circle C. And so an angle that has C as a vertex could be an angle like this. So what an arc is it's basically a piece of the perimeter of a circle, okay? So when you draw in this central angle, you can see it kind of divides the circle into two arcs. There's a small arc here, which is this curved piece, and then there's a large arc, which goes all the way around there. So that small arc and large arc is the differentiation between what is a minor and a major arc. So essentially these break down as to being more than half a circle or less than half a circle. So a minor arc is created when you have a central angle that is less than 180 degrees. Okay, so a central angle of less than 180 degrees, so less than half a circle. All right. Cuts out a minor arc of the circle. So if I were to do that in orange, this piece here, okay, this little piece of the perimeter of the circle is a minor arc. And just like a lot of other things in geometry, the naming is pretty intuitive. So it's named by the endpoints, like you would a line segment. And just like if you were naming a line segment, you would literally draw a line segment over that. This is an arc, so I'm actually going to draw a little bit of an arc. Okay, hopefully that makes sense. Now, the major arc is just what's essentially left over. So the major arc is just the points on the circle not included in the minor arc. Okay, so if I want to look at this major arc, right, so the rest of the circle here forms a major arc. The problem with this is that it also has endpoints of AB. So if I were to call this major arc AB, that could get a little confusing between minor arc AB. So what you have to do is we need a more specific name. So when you're naming arcs, if I know this is arc AB, what that means is there's no ambiguity as to do I go this way or do I go that way. Naming the arcs will always go with the shortest path. So if you have a two-letter name, okay, you're always going to be referring to the minor arc. So if I know it's arc AB, I know I'm going the short distance from A to B. To describe this long distance from A to B, I actually need to kind of, in the notation, say that I'm taking a detour. So I need a third point. I'm going to call this point D, and I'm going to call this arc ADB. So essentially it goes from A, so A and B are still the endpoints, but it basically tells me I have to go through D. So from A through D to B. And that is how the major arcs are going to be named. Now a semicircle is an arc with endpoints of a diameter. So remember, the diameter goes right through the center of the circle. It's the longest chord that you can draw. You could also think of this as just having a straight angle in the center. It's essentially a 180-degree central angle. So that goes into the discussion about measure. So how do we measure arcs? So there's two parts that we're going to be talking about. Their measure and their length. And at first it sounds like those things should be the same. But the measure of an arc is very much the same as talking about the measure of an angle. It's an angle measurement. It's basically an angular measurement of how much of the circle you take up. A circle is 360 degrees. So basically it's how many of that 360 degrees make up that arc. So if I make a central angle in here of 95 degrees, so the measure of angle ACB is 95 degrees. Okay, so the central angles all add up to 360 degrees. Okay, in a circle, the arc measures also add up to 360 degrees. So there's like a 1-to-1 correspondence there. So what that means is that the minor arc is the exact measure of the central angle. Okay, so the measure of a minor arc, is equal to the measure of the central angle. Okay, so that means that the measure of this arc AB, so measure of arc AB is how I'd write that, is 95 degrees. So it's the exact same measurement as the measure of the central angle. Okay, now that means if I want the major arc, okay, the sum of all the angles is 360 degrees, so you can just subtract them. So the measure of a major arc is 360 degrees minus the measure of the minor arc. So that means that the measure of the large arc, ADB, the major arc, is 360 minus the measure of the minor arc. So in this case, it's going to be 360 minus 95, which is 265 degrees. Okay? So for some examples here, the measure of arc RS is equal to the measure of the central angle RPS. So the measure of arc RS is 110 degrees. Measure of arc RTS, we don't know what this is. Oh, but it says the RT is a diameter. So that means that this is cut into 180 degrees on this side, 180 degrees on this side. It is a semicircle, okay, which means that the measure of arc RTS, the semicircle, is 180 degrees. And the measure of arc RST, I did this backwards. I'm sorry. This is the semicircle one. So the measure of arc RST, okay, this is the semicircle. RTS, my mistake, is going from R through T to S, going on this way. Okay, so this is the same thing as 360 minus the minor arc of RS. So this would be 360 degrees minus the 110. So this is going to be 250 degrees. All right. Now down here we have a survey asking students whether they'd rather meet famous musician, athlete, actor, inventor, or another person. And then shown in the chart, you can tell that the book is starting to get outdated because there'd probably be like YouTube star, like Twitch streamer. Like we're missing a lot of really important, like TikTok, viral dance creator. Like these things would be on here now, and it would make me shed a tear. So in this case, though, let's presume that students are normal and that they would actually rather meet athletes and musicians as opposed to TikTok stars and Twitch streamers. This uses something, I'm not going to take up space in the notes. It's the arc measure, the arc sum postulate, essentially meaning that if you have, say, an arc BCD, the measure of arc BCD is just the sum of the two minor arcs BC and CD. So essentially it just means you can add arcs together. It's pretty intuitive that you'd be able to do that. So the measure of arc AC is made up of these two arcs. So it's just the sum of 29 degrees and 108 degrees. So this is going to be 137. ACD, A to C to D, is the sum of these three arcs. AC we already have. It's 137. And then C to D is 83. And these things will add up to 220 degrees. Measure of arc ADC, A to D to C, is made up of the 79 degree arc plus the 61 degree arc plus the 83 degree arc. And this should add up to 223 degrees. This arc EBD goes all the way around except for DE. So it's actually probably easier for me to just do the 360 minus DE, because that's the only part that's not included. And this is 299 degrees. All right. So take a quick minute, pause this, try these practice questions, and then we'll fly through the answers in a second here. All right. So what you might want to do first is fill in this missing central angle if it's 100 degrees. And what do we have here? So TQ, this is a minor arc, and the measure of TQ is 120 degrees. QRT is a major arc, and the measure of arc QRT is 240 degrees. TQR is a semicircle. Okay, so that means that the measure of TQR is exactly 180 degrees. QS is again a minor arc, and the measure of QS is 160 degrees. TS is another minor arc, so the measure of TS is 80 degrees, and RST is another semicircle. So the measure of RST is 180 degrees. Okay. So the last new thing of today is the idea of congruent arcs. Remember, we know by now congruence is saying that the shapes are the exact same shape and the exact same size. So to achieve those, we need basically two things. The exact same shape means that the arcs must have the same measure. So they have the same measure. Okay, and so this takes care of the shape, right? So a minor arc will never be the same shape as a major arc. That's kind of the obvious differentiation there. And then to make sure that they're the same size, okay, they have to fit into one of these two situations. They have to either be in the same circle or in congruent circles. So circles of the same size. Now, if it's confusing that you have an and then you have an or, so you need this top thing, and then you need just one of these two. Okay? If it's kind of hard to keep track of, you can almost ignore this first part and know that they have to have the same measurement and they have to be in congruent circles. And just keep in mind that if they are in the same circle, that circle is clearly congruent to itself. So that would be sufficient. All right? So with these red arcs here, we've arc CD. Oh no. Oh no. Made that way too straight. So arc CD is congruent to arc EF. Okay? They are congruent because they both have a measure of 60 degrees. Okay, they have a central angle of 80 degrees. Okay? So they have the same measure, and they're in the same circle. All right. Here we have arc TU, which is not congruent to arc RS. Okay, so yes, they have the same measure. They both are 90 degrees, but they are not in congruent circles. Okay, so that's where the issue is. Okay, they're not in congruent circles. C, we have arc VX, and we have arc YZ. These are congruent because they have the same measure. Okay, they're both 95 degree arcs. They have central angles of 95 degrees. And they are in congruent circles. I know they're congruent because of this tick mark. So the circles have equal radii. And the radius is the only measurement in a circle. It's how that's how you define a circle, just by its radius. All right. So quick pause. Try these last two, and then we'll be all set. All right. For number 7, this one is a yes. Okay. You have the same measurements here. They are both 145 degree central angles. So the arcs are 145 degrees, and the radii are congruent. So you want to make sure you're stating those two things. And number 8 ends up being, no. They do have the same central angle, 120 degrees, 120 degrees, but here the circles are not congruent. Okay, so they have the same measurement, but they are in different circles that are not congruent. All right, good luck. Take care. Email me with any questions. I'll talk to you guys later.